Okay. Let me shut this down. Okay. All right, gentlemen. So let's see. No major announcements. If I guess the next thing I want to say, I don't think it pertains to anybody on the call right now because everybody that made it into the Zoom today, you had you on my roster. I guess there was I essentially kind of did a purge, but basically it only kind of pertains to people that have like an inordinate amount of unexcused absences. Where some people got dropped from my roster, but I made a disclaimer. I was like, okay, as long as you contact me and say, hey, I'd like to remain in the class and finish, then I make sure that you get back in there. So if you have a classmate who got purged or something like that and they want to finish, they just need to just get my attention and email first, just as on record. Or but it just needs to get my attention. And I basically just need an email with first and last name, the M number, and the course that they want to be added back to with the CRN. Then I can forward that to records. And they've been adding people back, but it's time time sensitive because you don't want something like being not being on a roster, not being in in your class or anything. You don't want something like that lingering. But like I say, I don't think that pertains to anybody on the call right now because everybody I laid in today or just now they were on my roster. What is that? I think that's okay. Okay. So let me see. We are in the home stretch. We have, I want to say, honestly, this is like the last of the new material. I was glancing at the calendar earlier today. Let me look at it again. So we have like this week, right? So I think today we're going to be working on. So this is like further topics in algebra. This is section 9.5, the binomial theorem. And then we'll pretty much be doing review after this week, right? So we have this week. Let me pull up my calendar real quick. Oh, I guess I keep forgetting that's. I gotta put that back. Let me see. So we have this week. We have next week. We'll probably just review. I might review like exams or something. But then that Monday, the 21st, we'll meet. But that Wednesday, the 23rd, right before Thanksgiving, we probably won't meet. Usually we have that Wednesday off, and we're remote. But yeah, we'll meet on the 21st, that Monday before Thanksgiving. More than likely, we have that Wednesday off. And then we have Thanksgiving, and then when we come back for Thanksgiving, we only meet that Monday and Wednesday. And then that Thursday and Friday, which is December 1st and 2nd, that's the reading period. And then that first week of December is the week of finals. So finals goes from December 5th through the 9th. So the things that are really important, if you're trying to improve your overall grade, you want to definitely go back. You want to prioritize your exams as they count for 80% of your overall grade. And then once your exam, you can earn up to 90% on those old assignments with unlimited attempts. And then if your exams are in order, then secondly, you want to prioritize your quizzes. And lastly, you want to prioritize the homework, where the homework it's a lot of work for minimal points, right? So I don't want you to stress about homework and quizzes. Those are like 10% each. It's not the bulk of your grade. The bulk is in the exams. And then, your final, it should become available. I think I scheduled it usually I schedule things to become available like Sundays at 11:11, but the hard deadline, everything locks out that Friday, December 9th, right? So if you need to go back and do anything, now is a good time to just get as many things in order as possible. You don't want to try to be waiting, because once December 9th hits, I can't push it back past that, because then I have to calculate final grades and submit them, right? So just trying to alert people so that you can get as many people positioned for success as possible, okay? As always, and again, what I mean by remote asynchronous, again, I do need you guys to check in and get your daily attendance credit. You don't have to stay, but I do need you to be checking in. So again, everybody on the call, you got your attendance credit for the day. Just, if you're like a no-show, then that just kind of mucks things up. It just makes things difficult. Yeah, that's the main thing, right? But aside from that, things are kind of done in a certain way just to make it as simple as possible for as many people as possible, but still doing what we need to do, right? Not being, kind of minimizing ego and some other things. Okay, so I think we're fine there. Let me check Zoom one more time, and I'll check it again around the 15-minute mark. You guys are looking good. Oh, somebody's on the call. That's interesting. I guess they called in, but that's fine. All right. Okay, cool. Yeah. So let's take some time to go through this section. So let me see. Dang on, I wish I had that thing. I gotta program it back. So let me see. There's one. So we really, I guess, including this week is what, 1, 2. Let's see, 1, 2, 3. We have like 3 full weeks and then like 2 half weeks remaining, right? Something like that. Hang on. 1, 2, 3. Sorry, 3 full weeks and then an extra day remaining. So if this is the last week of new material, so that means we'll have approximately 2.5 weeks of review, where we could basically take an exam per week, right? We can review 1 exam per week in preparation for the final exam. And so for the final exam, you can anticipate it to be cumulative, basically everything from the beginning, a little bit of everything from the beginning to the end. And you can anticipate it pretty much being the same way that we've done our previous exams, where it's basically going to be unlimited attempts until December 9th, right? So there's no late thing because I can't push it past the 9th, but you get unlimited attempts for those 5 days. So that's Sunday to that Friday, right? Okay. And so we'll take an exam per week to review leading up to the final. And I think that'll get us there. Okay. All right. So with section 9.5, we have the binomial theorem and a few objectives. We'd like to use Pascal's triangle to commute binomial coefficients, use Pascal's triangle to expand a binomial power, use the binomial theorem to expand a binomial power, and find the coefficients of a term in a binomial expansion. Okay. So let's start off with what do we mean by a binomial expansion? Part 1 of 3. It says the patterns for the expansion of here. Let's go like this. The patterns for expansions of this binomial, where n could be 1, 2, 3, 4, 5, any non-negative integer, suggest the following. The expansion of this has n plus 1 terms. Okay, I see it. Yeah. I paused because I was thinking like, okay, say this was 2, right? When a square, when you expand a square binomial, then you do get 3 terms, right? So 2 plus 1 is 3, so on and so on. The sum of the exponents on x and y in each term equals n. Okay, that's fine. The exponent on x starts at n in the first term and decreases by 1 for each term unit until it's 0, and the last term y until it reaches 0 in the last term. Okay, that's fine. So the powers for x go from n until down to 0, and they decrease by 1 until each one. Let me see. There should be some more. The exponent on y starts at 0 in the first term and increases by 1 for each term until it is n in the last term, right? So we're going to see all this in action. It's a little bit information overload to just kind of say it. This is just kind of like introducing it, but then once we work a few examples, these properties or these like concepts will kind of become inherent, or it'll make sense once you see it a few times. The variables x and y have symmetrical roles. That is, replacing x with y and y with x in the expansion of x plus y to the n yields the same terms, just in reversed order. Okay. It said it's the third one. Oh, there it is. You may also have noticed that the coefficients of the first and last term are both 1, and the coefficients of the second and next to last terms are equal in general. So the coefficients, these are equal for j from 0 to 1 to n. The coefficients in the binomial expansion are called the binomial coefficients. Again, these will come out once we start kind of expanding a few. You'll see it. You'll see the coefficients and all of this stuff in action. So when expanding a binomial to the power of n, it says the coefficients of each term can be determined using Pascal's triangle. We'll talk about that in just a moment. The top row of the triangle, which contains only the number 1, represents the coefficient of x to the power of 0, and is referred to as the zeroth row. The next row, called the first row, represents the coefficients of x plus y to the power of 1. Each row begins and ends with 1, and then each entry of Pascal's triangle is found by adding the 2 neighboring entries in the previous row. That's fine. Okay. Let's build it. I want to build it manually for a moment. We see it there, but I just want to build it manually. Oh, for some reason, this thing always crashes when I try to add a page, and I don't really know why. Give me just a moment. Can you guys see the screen? Hopefully that's been resolved. Okay, let me see if this works now. Okay, and then this one. There we go. Apply. All right. So I just want to do a quick expansion. Let's just build Pascal's triangle. So Pascal's triangle, let me see. Let's do paper. Let's do this. This is fine. Okay. So we'll start off with like row 0, right? So we'll put it like here. It's just the 1, and why is that like that? Okay, I guess that's fine. Okay, so row 0 is just going to be like a 1, right? And then let's do row 1. So that's going to be here. Let's move this a little bit closer. And then so row 1 is going to be it's going to be 1 and 1, something like that, right? Okay. So then now when we look at row 2, and we'll see the application. I just want to show you how to build Pascal's triangle. So then, for instance,
Professor.
Yes.
I can't see the screen.
Can't see the screen. Okay.
What you are
let's
writing?
try it again. Okay, hang on. This here. Let's see. Let's do it. And just do it. Okay. And let's try this again. Screen. Start the broadcast. Okay. You should be able, hang on. You should be able to see it now. Okay. And just let me know if you can't. Okay. So for instance, row 0 is just 1 and 1, and then row 1 is like this, okay? So then when we go to row 2, the first number in any row is a 1. So this will be like a 1 here. The first and the last are both 1s. And then, so for instance, 1 plus 1 is a 2, so there's a 2 there. Right? And then you finish with a 1. All right, that's row 2. Let's do a few more rows. So then let's do like row 3. Okay.
I think your screen froze. We can't see what you're doing.
You still can't see it?
No.
I need you to stay on the line because I don't understand why you guys can't see it. Let me see. What is this? Enabled. Okay, let me see. Share my screen. Go to the application. Screen. Let me, can you see it? Can you see it now? Hello? Hello?
Yeah, we can see it. Yeah, we can see that.
Okay, just let me know if it goes out again. So for row 3, each row starts at 1. Let's see. So we'll put like a 1 there. And then for the next part, let's do it like this. So 1 plus 2 is 3, right? So that tells you, basically you just add the adjacent ones, entries to get to the next one. So like 1 plus 2 gives us 3, 2 plus 1 gives us 3, and then the last number is a 1. Let's do a few more. So then if we did row 4, right? First entry is a 1. And same kind of deal. You just add that, you add this, you add that. So then 1 plus 3 is 4. 3 plus 3 is what? 6, 4, 1. Let's go ahead and do a few more. Row 5 starts with a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then it finishes with the 1. Let's do like at least one more. 6. So it starts with the 1. 1 plus 5 is 6. 15, 20, 15, 6, and 1, right? And it just continues that pattern, you know, on and on and on. So this is Pascal's triangle. Let's go like this. Paper. Like this. Right? So it kind of grows in a fashion like that, right? And so that's just, and it just keeps going, right? So you're not going to build Pascal's triangle every time, but you know, it's constructed in that manner. And so what this is, mathematicians notice that when you start doing these binomial expansions, did it cut out again?
No.
Okay. When you start doing the binomial expansions, the coefficients in front of the numbers all come from this triangle, right? So let's see how to apply this in the expansion of binomials. Let's just see it in just a moment. Right? Okay. So let's take this one for instance. So this is an example on using binomials triangle to expand this binomial. Okay, let me think about it. So if we want to expand this guy, I'm trying to think, do I need some paper? Look. Oh, is it going to crash? I mean, hopefully it doesn't crash. I want to give myself some space. Okay, that's looking good. Let's go. Not that one. Cancel. Single. Okay. All right. So we'll start here. Okay. So now if we want to expand this guy, let's, anybody got a favorite color?
Red.
Red.
Yeah, and what's your other favorite color?
Black.
Aside from black. One more.
Blue.
Blue, okay. So let's expand this guy. Okay. So now when we go to expand it, let me see. There's a pattern, right? So just focus on the colors, right? So if we have this 4 to the y, we're gonna let that be the first part, and we're gonna come back and add some stuff to this. And then we have this 2 to the x, right? The x's, the first term has to count down, right? So this starts at a power of 5, and this other one starts at a power of 0. And because this is to the power of 5, on Pascal's triangle, we're going to use row 5, right? So we're at 1, 5, 10, 10, 5, 1. We're going to use that one. So that means the first coefficient is a 1 there. So there's a 1 here. Okay, I think that's everything. So let's keep going. So now we say plus. I think the next part was a 5, right? So the 5 comes from Pascal's triangle. Now the red, we start counting down on the powers. So we just have 4 to the y, but now it's to the power of 4. And the blue, we start counting up. 2x to the power of 1, right? And actually, there's one other thing. We need to keep track of that sign. That it's a negative 2x. Same thing here. It's a negative 2x. Okay. Okay, so then we just continue that pattern until we get to the end. So then the next one, I think it was what? Was 10 on Pascal's triangle. If the red is counting down, so then that was 4y. Now it's going to be to the power of 3. And the blue is counting up, so that's going to be a negative 2x squared. And then we just go to the next part, plus. Right, so the black is the application of Pascal's triangle. And then the first term, the powers are counting down. The blue term, the second term, the powers are counting up. And you just go until you get to the end. You just continue that pattern. I think it was 10 again on Pascal's triangle. Okay. And then 4y, now it should be what, squared? And the blue, 0, 1, 2 should be cubed, right? Notice that the powers always add up to 5. Right, so that's another thing to kind of check as you go. And let's just keep going. We're almost there. I think it starts to come down now. So then I think it's 5. Let me check one more time. Yeah. All right, so this is coming, the coefficients are coming directly from Pascal's triangle. Then we have 4y to the power of 1, and the blue is power of 4 now. And then I think this is the last one. It's going to be a 1 from Pascal's triangle. The red is now power of 0. Now, obviously, we have a faster way, but this is just like, showing you just some interesting things. And power of 5, right? I think that's, and so then we go back and simplify everything. So let me see. Power of 0, that means this is a 1. This is 1, right? So in that first term, we're just left with 4 to the power of 5. Hey Siri, what's 4 to the power of 5?
4 to the 5th power is 1024.
Y to the power of 5, okay. The next one is going to be negative. Okay. Is it 256? It could be. I think so. Hey Siri, what's 4 to the power of 4?
4 to the 4th power is 256.
256. So, right. And then we're going to have y to the power of 4 times x, okay? 16 times 4, 64. Here, let's do this. Hey Siri, what's 10 times 4 to the power of 3 times 2 squared?
10 times 4 cubed times 2 squared is 2,560.
2,560, is that right? 440, 4 to the 4, 10. I guess so. It could be. y cubed, and x squared, right? Almost there. So the next one's going to be negative. 8 times 16, 80 plus 48, 128. Y squared, x cubed, 16. It's going to be positive 16 times 20, 32, so 320. One more. It's going to be negative 32 times 464, 128. Sorry. Nope. This guy goes to 1. So it's going to be 32 x to the 5th power. Okay, let me just do this really quickly. Okay, so it's not going to let me move the way I want to move it. Okay. Let me see. So we got a double 2560. Let's see. That's fine. Yeah, they got it there. 1024, 2560, 1280, 320. No. Ooh, I thought we lost that word. Let me get rid of this extra page. It looks like we didn't need it. I think we're okay. Let's see. 1024, negative 2560, plus 2560, negative 1280, plus 320, minus 32. Yeah, it looks good. All right, let's do view, single page. Okay. So hopefully that made sense. So you see the type version here. Let me box my final answer. All right, so we saw the expansion with the application of Pascal's triangle. We saw how to construct Pascal's triangle. Now there's a faster way. There's another way to get rid of to generate those coefficients instead of using Pascal's triangles. Like what if you were on like the 16th row, right? You wouldn't do Pascal's triangle all the way down there, right? Or something that's further beyond, right? So we have a way to jump straight to those coefficients. Okay. That was fine. Okay. So that's what this is. This is called the binomial coefficient, this guy here. This is read as n choose r. This comes out of, I know I first saw this when we were doing like probability. It's like in counting. And so it's like if you have n objects taken r at a time where you don't count repeating sets, right? So like if you had 5 objects, you want to see how many ways can you choose 5 objects taking like 3 at a time? And this is the combination. So you would like, you don't want to count repeats in this case. That's where I first saw the symbol, but that's called the binomial coefficient. And let's get into like where this comes from. So if r and n are integers where r is greater than or equal to 0, but less than or equal to n, right? So r has to be less than n, but greater than 0. We define this symbol as n factorial divided by r factorial times n minus r factorial. And just to kind of recap, factorial, the exclamation mark, what it means is you take that number times the next number down times the next number below that, and you multiply all the way until you get down to 1, right? So like for instance, 4 factorial means 4 times 3 times 2 times 1. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1, right? If you ever come across 0 factorial by definition is 1, okay? And so if you were to apply this binomial coefficient using this formula, eventually you're going to come across 0 factorial. And again, by definition, just so this stuff works, 0 factorial means 1. Okay. So when we do n choose 0 or n choose n, they both are going to end up being 1. Okay. So this is the, go ahead.
It's kind of off track, but like, when are finals and how do we do them?
So in the past, like, so with this remote, what we've been doing for the final is just, we just pretty much hold it just like we did all the other exams. It's just that finals are that first week of December. So this stuff is going to be over in the blink of an eye, right? That's the kind of stuff that we talked about at the beginning of class. Like, we have this week a lecture. This is the last of the new material. So next week, we're going to start reviewing for the final. We're going to take basically one exam per week in preparation for the final to review. So next week, we'll review exam 1. The following week after that, we meet on that Monday before Thanksgiving. And then more than likely, we're off on that Wednesday before Thanksgiving. So then we have the Thanksgiving break. When we come back from Thanksgiving, we meet on that Monday and Wednesday. That Thursday and Friday, not that we meet on Thursdays and Fridays, but Thursday and Friday after Thanksgiving, the following week is usually our reading period. And then the week after that, that first week of December is finals, right? So that the first full week of December are finals. What that means is that we have a hard deadline for all of our assignments is that Friday, December 9th at 11:59 p.m. I can't push anything back past that because at that point I have to start calculating for final grades. Okay.
Yeah.
Yeah. Okay. So let's keep going. All right. And there's a couple of ways I like to kind of crunch these binomial coefficients. We'll start off using this formula, but there's another technique that I like to use that I feel like is a lot more simple to calculate these numbers. But let's work a few of them. Will this be enough space? I think I want to give myself some space because I want to work both of them. Hopefully it doesn't like conk out on me. Okay, it looks like it's okay. And let's change the view to seamless. Okay. So let me start by doing each one, applying the formula, right? And I guess it doesn't hurt to go ahead and write the formula. So n choose r. All right, this is going to be n factorial over r factorial times n minus r factorial, right? Okay, so then if we work in part A, so 4 choose 1 means we're going to do 4 factorial over 1 factorial times 4 minus 1 factorial, okay? So then 4 factorial means 4 times 3 times 2 times 1, right? 1 factorial is just 1, and then 4 minus 1 is 3. So 3 factorial is going to be 3 times 2 times 1. Okay. So then notice these factors are going to cancel these factors. And then so that one just ends up being 4. Okay. So yeah, let's do a few more. So for part B, we have 5 choose 3. Actually, let me try. Okay, I was pausing because I was trying to think of how to introduce the other technique. So this binomial coefficient in this form, this n choose r, another way you might see me write it, you might see me write it as 4 choose 1, right? That's combination. This is the same thing. These are the same. So with combinations, then we have this thing called permutations, but I feel like that's bringing in too much. Let me just try this other technique. So we have 5 choose 3, right? 5 choose 3. So another way, and I'm going to do this in purple because I'm just trying to introduce this other concept, is using permutation where it would be 5p3 over 3 factorial, right? And what I mean by 5p3, that's like basically, it's like 5 factorial, but you only go out 3 spaces, right? So 5 permutate 3, the way you calculate that is going to be 5 times 4 times 3. And on bottom, 3 factorial is 3 times 2 times 1. So then this is really 5 times 4 over 2. So then this is 10, all right? So you can choose whichever technique you resonate more with. I just wanted to show you the purple one. I prefer to do it the purple way. You might see me just jump straight to that sometimes. And we can, like, if we try to apply that to the previous one, it's the same as 4p1 over 1 factorial. So then what that means is you would do 4 factorial, but you only go out one space. So it would just be 4 over 1, and you get the same result, right? And if we were to redo this one using the formula that we had before, it would be 5 factorial over 3 factorial times 5 minus 3 factorial, right? So then 5, 4, 3, 2, 1 over 3, 2, 1 times 5 minus 3 is 2, so 2 times 1, right? So then if you start canceling, this cancels this, and notice you have the same thing that we had before. This guy is equal to that guy. And so we finish with the same result. Okay, let's try a few more. We got a few more minutes. I want to say I have the full lecture. I'm under the impression I did all my full lectures. So now with this one, 9 choose 0. You could just put a 1, or if you wanted to apply like the formula that we had earlier, it would be 9 factorial over 0 factorial times 9 minus 0 factorial. Remember, 0 factorial by definition is a 1. This would really be 9, 8, 7, 6, 5, 4, 3, 2, 1 over. Okay, instead of writing all of that, which is nothing wrong with what we did, but this is really 9 factorial over 9 factorial. A number divided by itself is just 1. So whenever you see not like a number choose 0 or a number choose itself, the result is 1. Because you're going to get to a line that should look like this, a number divided by itself, right? That was part C. And then part D is 35 choose 35. 35 choose 35. Again, you don't have to write that all the way out. Long story short, it's going to be 35 factorial over 35 factorial times 35 minus 35 factorial. Long story short, this is just 35 factorial over 35 factorial, which is still 1. So these two cases, you know, a number choose 0 or a number choose itself. These are just 1. Hopefully that was okay. Let's keep going for at least the next 5 minutes. I feel like, you know, it's kind of a crash course. Let's just try another one. 4, 10. I think we got all of these. 1 and 1. Okay. Okay. So the binomial theorem, right? So now we saw how to expand binomials, right? Where the coefficient came from Pascal's triangle, and then the first term, the powers on the first term were counting down from n down to 0, and the second term, the powers were counting up from 0 up to n, right? So now, instead of using Pascal's triangle, we can actually do the binomial coefficient. We can use this guy and generate that coefficient instead of trying to use the triangle, right? So when using, so everything else is the same with the powers of the first term counting down and the second power counting up. The only difference is now these binomial coefficients are going to be in, first you go 0, then you go 1, then you go 2, then you go 3, and you keep going until you get to n. All right. And then you have to on the side calculate all these binomial coefficients and incorporate them into the technique that we did earlier, right? That's what all of this is saying. Okay. Let's try to do one more and then that'll be it. So find the binomial expansion of this guy. Okay. I'm gonna give myself some space. I'm gonna add a page. Cool. And let me change the view to seamless. Okay. So we're asked to expand this guy. Okay. So we'll do the binomial coefficient in black. Let me see. So we're going to have 4. We're going to start off with 4 choose 0. And then the first term, I think we had it in red. So we're going to say times x. It's going to start off to the power of 4. And then the second term is this negative 3y. Keep track of that negative because it's very easy to lose it, to the power of 0, right? And one thing I want you to notice, those two match. The two blues, they match, right? So then let's keep going. So the next one is going to be 4 choose 1. Okay. The reds are counting down. The blues are counting up. Right. So if you like puzzles, that's what all of this is. These are just puzzles and games. It's just, we're just trying to get you caught up to what other people have figured out. Instead of trying to reinvent the wheel, we're trying to show you what people have noticed. This is a game of like noticing, but it's hard to notice when you're like, you know, having to work and go to school and take care of family and live your life, you know, and, you know, this, that, and the other. But I feel like we're on the cusp of a golden age, because if we weren't concerned with like money and stuff, then we can further advances in this. But if you're not, you know, if you don't have that kind of time, which many people don't, then, you know, it's hard to think about stuff like this. 4 3 2. So this is still counting down, and I think that's counting up. So negative 3y squared. Okay. Let's keep going. I'm watching the clock. We're just about out of time. Let's see, 0, 1, 2. So now we're on 3. So 4 choose 3. I feel like these colors help a lot to show you like what goes with what. So that should be power of 1, and the blue is now power of 3. And I think we got one more. Then we have 4 choose 4. Okay. Reds are still counting down. This is the final one. And the blue is counting up to 4. Okay. So, all right. So then, now the next part, 4 choose 0 is just going to be a 1. I guess I could do that in this one. So that's a 1. Okay. We're still going to have our x to the power of 4. And then this guy is 1, so we don't have to write it. Okay, and we're going to say plus. 4 choose 1 is 4. This is going to stay as x cubed. And we're going to have times, it's going to be a negative 3y. Okay, we're just going to leave it like that for right now. Okay. So then 4 choose 2. So the way I do that one is basically 4 times 3 divided by 2 times 1. It's like 4 factorial over 2 factorial, but the 4, you only go out 2 spaces. All right. I'm wrapping up. So 4 times 3 over 2 times 1 is 6. Okay. If I need to write it out, I can, but that one should be 6. The x squared persists. And that one is now going to become a positive 9y squared. Okay, let's keep going. Plus. So I think that one is just 4. Okay. X to the power of 1. Let's see, that's going to be a negative. 9 times 3 is 27 y cubed. And then the final one, that's going to be a 1. The red is 1, the blue, 81 positive. Okay. Then we just need to do one more step to put all this together. Okay. Let's see. So the final thing we get is x to the power of 4. 4 times 3 is what? 12. So it looks like it's a negative 12 x cubed y. 54. So plus 54 x squared y squared. Okay. Plus 80 plus 28 is 108, negative 108. So that needs to be a negative 108 x y cubed. And then it looks like we finish with plus 81y to the 4. Okay. Let's, I'm going to shrink this down to get it on one page. I see the time. I'm getting you guys out of here. Just want to see how do we do with our work. Right there. Okay, let me get rid of this guy. Delete. Ooh, and let's go. We can leave it like this. Okay. So let me see. Can I see them together? There it is. So we got x to the 4 minus 12 x cubed y plus 54 x squared y squared minus 108 y. Is the x gone there? X to the power of 1, right? Yeah, I think they made a typo. They're missing x to the power of 1. Let me look at it again. 4 times x, right? Yeah, right here. They're missing an x, but that's fine. Minus 108 xy cubed. That's supposed to be x there plus 81 y to the 4. Okay. So they're missing an x right here. Okay. All right, let's do view, single page. Okay. Get rid of this. All right. So, but yeah, we did it, but you saw the demo. Hopefully that was okay. Let me see, particular term. So, you know, this part talks about how to jump straight to a particular term, but we are out of time. I would encourage you to, you know, reference my pre-recorded video for the remaining parts. It's not that much more. But yeah, are there any questions before we go our separate ways? Any questions, guys? Okay. Let me just go ahead and make a copy of this available for you. Send it to Box. Not College Algebra 1. Fall 2. Notes. Updated daily. This is week, what, 13 plus 12 was an exam. We're good to go. Send the Box. Okay. So when this bar finishes loading, you'll get a copy of everything that you saw me writing. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Okay. Take care. Peace. Yeah, I don't know what was going on with the screen.